So the first thing we looked at were sequences. We looked at sequences first. Now sequences was an ordering of numbers that have a relationship. They follow a rule. And you can have a finite sequence or an infinite sequence. Okay, meaning like you can have a sequence that only has 4 terms in it, or you can have a sequence that has an infinite number of terms. You can also have these other things called series. Now series are related to sequences because it takes the sequence and adds them together. That's a series. It takes a sequence and adds them together. One way to show this, to write it, is using something called sigma notation, which is what you see right here. What it means, well, let me just, okay, this right here is the rule. You guys remember the rule before, like we had the nth term for a sequence? That's that. I mean, it's using I instead of n, but that's the rule. That's how you find the sequence of numbers. Right here is your starting point. That's where you start. And right here is where you stop. Okay, so let me explain this a little further. So, I mean, this is representing a series. But what is the sequence that it's adding together? Well, we can find our sequence by looking at the 3i like it's, let's say a sub I equals 3i. And so that means a sub 1 would equal what? 3. A sub 2 would equal 6, and then a sub 3 would equal 9. And then what would a sub 4 equal? 12. And then a sub 5 is the last one that I would need to do. 15. Now why is a sub 5 the last one I need to do?
Because it says that's the stop.
Yeah, that says stop. Okay. Now I'm writing it out like that because you guys are used to seeing the sequences written out like that. How many terms are represented here?
5.
Okay, there's 5 of them. All right, and since it's in summation notation, what this is telling you to do is saying take all these numbers in your sequence and add them together. So it's going to be 3 plus 6 plus 9 plus 12 plus 15. What do you guys get? 45. Okay, now I heard the questions asked, so I will say yes, there is a button for this on your calculator. Right now, for the graphing calculator, I can't think of it off the top of my head, but I don't know how to use that one. It's sigma. Stop saying e. And then I think the Casios have it. The Casio scientific calculators, they have the sigma button, which is why you won't be allowed to use that on your use calculators on your test. For this next one, I want to show you guys a trick. You don't have to use a trick. It's just, I want you to know it's there. Sigma notation has certain properties, and you can do it this way if you so choose. It comes in handy for some problems. It really does. Now, there's a plus inside of this one. What you can do is you can split it up. You can write this twice and split it up. And it has its advantages. See, so you would write it like this. You go sigma, and you put the k equals 3 on the bottom, and you have 6 on the top, that's where we stop, and you put 1. Then you say plus, let's do it in red. This plus sign is this plus sign. I'm going to write the sigma, and then I have k equals 3, I have the 6, and k squared. So this is what you can do with sigma. Like, you don't have to do it this way. You can solve this the same way we did this one, where you list all the terms like that and then add them together. That's not a problem. Okay, but there's a trick. Now, let's think about this one right here. It says k starts at 3, which is different. It doesn't start at 0, it doesn't start at 1. It starts at 3. So what's the first number that you plug in?
3.
You would plug in 3. Okay, but this one's weird because you look at the rule, there's no k in there. So there's no place to plug in the 3. That just means when you plug in 3, you get 1. When you plug in 4, what do you get?
1.
You get 1. When you plug in 5, what do you get?
1.
You get 1. When I plug in 6, what do you get? 1. Do I plug in anything else? No. No, you're done.
So it's 4.
So that is 4. Let's put my plus sign right here. And this is going to be 4 right here. And then there's my plus sign again. Okay, so for this one right here, we got a little more work to do. It's going to be 3 squared plus 4 squared plus 5 squared plus 6 squared. And what's that? Should be a red plus. Okay, so we have 9 plus 16 plus 25 plus 36. Now you just have to add all those bad boys up.
86.
And you're done. Did I say 86?
Yeah.
36. Sorry, I do that sometimes. Okay, what is that when you add all those up?
86.
90?
90.
Was 90 when you add, isn't it? 80
Yeah, it's 90. I think it's 90.
It is.
Can you guys double check it?
My calculator says 90.
Now this last one's really interesting because it has the I on the denominator. How many terms is this one going to have?
8.
8.
Not 8, because you got to count the 0.
9.
It has 9 terms. What is a sub 0 for this one? It's going to be 1 over 0 factorial. What is 0 factorial?
0.
It's not 0.
And negative 0.
It's 1.
What's that?
Wait.
I know, it's kind of weird. 0 factorial is 1 because the identity in the multiplicative universe is 1. The identity number is 1. But you don't need to worry about that. You just need to know that 0 factorial is 1. So I have, if I plug in 1, what do I get? 1. Oh. If I plug in 2, what do I get? So I have 1 over 2 factorial. What is 2 factorial?
Times 1.
So it's just 1/2. And next one I have a sub 3, a sub 3, it'd be 1 over 3 factorial. Oops. And 3 factorial is 6. Next one is a sub 4, 1 over 4 factorial. Bam! Alright, so I did them all. Now, what do I have to do with all these numbers in this sequence? You gotta add them all up.
Wait, why'd you go 10?
Alright, so I'll give you guys time. Punch me in your calculator right now. Tell me what you get.
I can't do this.
Good point.
Now, when you add all these fractions up, only certain calculators would leave it in fraction form. Most calculators will put it in decimal form because that's just how they're designed, I suppose. But decimal form is not as fun because it's an approximate number. Anyways, you should get 2.71828, which actually is really close to another known number. Do you guys know what that number is really close to?
Isn't it 2.7? Or did you round it?
No, it's really close to this number known as E. E is the natural base.
Yeah.
Yeah, kind of interesting.
Wasn't that the opposite of?
Here's the formal definition of summation notation. It's in your book. I wanted to point out a couple of vocabulary words. Summation. The index number of summation is right here. It's the I. Okay, it's whatever letter is right there. That's the index number. And then there's the upper limit. The upper limit of the summation is n. Whatever number is right there, that's your upper limit. Okay. Let's see. Where's the 1? Oh yeah, and 1 is your lower limit. So that's the other number. Okay. And then I told you guys that this one right here, the a sub I, that's your rule. That's the sequence right there that you are going to be adding together. The other information that you can know, these are the tricks. I showed you guys one of these tricks already. This trick right here I showed you. If you have two things going on here that's adding inside the summation, you could split it up like this. Okay, and I did that one for you guys. This one's interesting. It'll lessen your workload if you have a number. If you have a number that's multiplying to the rule, the a sub I is the rule. If you have a number multiplying, you could take that number out and just multiply it to the final product that you get.
The whole final product?
Yeah, the whole final product. So at the end, after everything's added, you just multiply it by that constant, and you'll get the same answer. And this one is obvious. It kind of matches 3.